That was even in pre-calculus, as limit goes to infinity or as limit goes to a number, we would give you methods, right? Now, here when you have form 0 over 0, there's a few things that doesn't require extreme algebra that we can give you to do. And one of them is that if the limit doesn't exist, and one of them is when some of them require limit doesn't exist, some of them require limit exists. My rule of thumb here is this. Do you see that I have x to the power 2, y to the power 2? So if the denominator, everything in the denominator is to power even, then I will have a discussion. I need some recognition whether or not the limit exists. When things have basically power odds, there's a better chance that I have the limit doesn't exist. And so when all the new denominator are of power even, then I look at the minimum power I'm getting in here, and I compare it to the top. I look at the powers I'm getting in here. See, here I have all the same powers, 2. And the powers I'm getting on top are 2 also. So since all these limits are going to 0, 0, that sort of tells me that the 0 on top and 0 on the bottom are of the same power. Or if I plug in polar coordinates, R's are going to simplify. So this one tells me R from top and bottom simplifies. And sort of you end up with this theta. If I plug in polar coordinates, you end up with this expression of theta that would just go crazy, and for every theta it gets different values. Right? So I tag this as I suspect this doesn't have a limit. Suspect for no limit. Now, with that one, I realize if I plug in polar coordinates, then 1R stays on top. So this is my suspect for limit exists and squeeze theorem. Go down here, again the same thing happens. Again, suspect. Why am I saying this? Because there's like so many little details. These powers on top are bigger than powers in the bottom. Powers in the bottom are even. Suspect for squeeze theorem. Here, I see that the powers on top, power from bottom are the same. So R will simplify, so suspect for does not exist. Here, when I try to do this, I sort of figure out my first instinct is, oh, this is all mixed up, so I better try both sides. And then over here again, I know, look at this. If I plug in R from top and bottom, simplifies. So again, suspect for does not exist. And that one, Now, let's try to do at least 2 of these and figure out how to do these problems. So, one, do A, maybe 3 of these, right? I think the one that requires the limit exists is easily done. It's not easily done. It's going to be very similar across. So I do one that limit doesn't exist first, and then do one more later. A, limit of 2x squared plus 3xy plus 4y squared over 3x squared plus 5y squared. Now, I suspect the limit doesn't exist. So I try to find 2 paths. A lot of times people even try x equal to 0 and y equal to 0. X equal to 0 and y equal to 0 is that you're basically, for this one, you're parameterizing a curve 0 and y. For that one is x and 0. The parameterization is that. And these are in the domain. One is this. The second one is that. Parameterization is this. So this limit changes to limit, plug in 0 for x, y for y, and you get 4y squared over 5y squared. And here, parameter is y goes to 0. And then these two simplify, the limit becomes 4/5. Everybody with me? Now, part 2. Let's see if this is going to give me a different limit. If it's the same limit, it's useless, right? So I'm aiming for different limits. Now I'm plugging in limit. And for y, I'm plugging in 0. So let me write this down, part 1, part 2. So limit, and then for x, I plug in x. For y, I plug in 0. And then parameter goes to 0, x and x squared and x squared simplify, and I get 2/3. Good. If these two were the same, I did nothing. I have to do other stuff, but they are different. So I have 4/5 not equal to 2/3, DNE. Because I found 2 paths that gave me different limits, basically. Okay. That was one of these. Let's do one of the suspects for limit exist. Oops, sorry. Let me write down a limit that I suspect exist. E, limit as x and y goes to 0, 0, for x squared y over x squared plus 1 squared. Okay. So I suspect this one exists. Again, why? Because I have x to the power 2 plus, and then y to the power 1. That's r to the power 3 in my mind. And in the bottom, I have r to the power 2. So I know that the r is stronger on top. 0 on top is fastest and is a better 0 than the bottom, and it simplifies. So what do? I do the polar coordinates. And so goes limit, replace x by that. Don't forget the powers. Replace y by that. And then I get this. R goes to 0. Theta can go crazy as much as they want to. So what I end up with, if I factor the bottom, if I factor r squared, I end up with sine squared theta plus cosine squared theta. It's just r squared. This r squared and that r squared are going to simplify. So what is left is limit as r goes to 0, theta goes to anywhere, r sine theta, cosine squared theta, and that's it. No, 4. Did I do it right? I did right. Okay. Now, here, this thing, this part, you see the part that can go crazy and oscillates heavily as theta changes all around point origin. That one changes all around as theta changes around the origin. This part, even though it's crazy, there's no denominator. There's nothing to worry about. Sometimes denominators, you can figure out that they don't go to 0, but there's no denominator here, so I don't even have to worry about that. It's very nicely bounded function, bounded. So basically, I can put in 4 in there with it too. 4 sine theta cosine squared theta. Sine theta is between -1 and 1. Cosine squared theta is between 0 and 1. So the product of the 2 n times 4 is going to be between 4 and -4. Bounded. Right? So if I multiply everything by r, I realize that limit of 4r as r goes to 0 is 0. Limit of -4r as r goes to 0 is 0. So limit of that one exists by squeeze theorem, by squeeze. Limit of 4r sine theta cosine squared theta as r goes to 0 is equal to 0. So the limit exists, and by squeeze theorem is 0. The trick was, I'm not, I want to hear that you know that it's something. R is an expression that goes to 0, and the other expression is bounded. So give me a bound for the rest of it. I say bounded function times the function that goes to 0. This product goes to 0 by squeeze theorem. So if this wasn't bounded, it wouldn't work. For example, if you had done it over here, there are other examples that you can see that that part is not bounded, so you cannot use the squeeze theorem. Questions? No, all good? Did this make sense? Okay. So that was that. I'm kind of going slower. This semester, I'm just slowing down. I don't know why. Sorry about that. Okay, so let me do, which problem do you want me to do? Oh, let's do E and see what happens in E. So in here, again, it was one of those that I wasn't so sure. Again, E is not that. There are tricks, and you can categorize every one of these. But it's just not wise, because there's so many little, if this is that, then that is this. You have to memorize all of that. So the best way is to mildly know that you're basically working with R, sorry. And then after that, you want to know that after knowing you're working with R, then you have suspect. Suspect for limit exists, suspect for limit doesn't exist. So if you think that the power of R in the numerator is bigger than denominator, that is a very good suspect for limit exists. If otherwise, good suspect for limit does not exist. So how do I deal with this? I have a feeling if I plug in R, then and you can try to plug in R. And see that you cannot have, you will not have R or R to a power times bounded. So as soon as you do that, you say, okay, this was one of the suspects that could have gone either way. Now I know I can go that way, so maybe I try to find paths. So the first path that you think of could be x equal to 0, and the second path could be y equal to 0. Let me tell you why y equal to 0 is no good to me. First, let's do path x equal to 0. So it's x 0 and y. Limit as y goes to 0, plug in 0 for x, and you get 0 over y to the 8, and that is equal to 0. Okay. As soon as I go past y equal to 0, I end up with the same routine. So y equal to 0 path, y equal to 0 is no good to me. It gives the same limit. Now, what do? I use path. Well, I try to do this little trick. I try to equalize things in there. How do I do that? Look at this. On top, I have x and y to the 4th. On the bottom, I have x squared and y to the 8th. Wait a minute. If I equalize x and y to the 4th, if I go a path x equal to y to the 4th, then I will end up with y to the 8th in the bottom plus y to the 8th. It's just equalizing the exponent sort of thing. And that usually is one of the helpful paths for when you have this type of mess, you will figure out, well, x and y to the 4th, if they were the same power, then these two terms will be the same power in the bottom. So I choose x equal to y to the 4th. Now, this path is y to the 4th and y. So limit as y goes to 0, and I replace for x y to the 4th, y to the 4th, y to the 8th, plus y to the 8th. And this is limit as y goes to 0, y to the 8th, divided by 2y to the 8th, and that is 1/2. Now, this actually gave me something precious. Because the two limits are not equal, I can say easily DNE. Questions on limits? Moving forward. Yes. Loud. Okay, I'll do it one more quick. Let me see. So going back to the suspecting limits, where did I put it? Oh, there we go. Going back in suspecting limits, what I did is that I added up, see each term. When I say I add up each terms to get, I just imagine X is R cosine theta, Y is R sine theta. So I add up the power for R. On top of here is R to power 3. On the bottom is R to power 2. So R to power 2 is stronger than R to power 3 is stronger than R to power 2. They simplify and I still will have a 0 in the numerator. So that's why I suspect squeeze term. Over here, the same thing. Over there, if I just look at all the powers of R and I see 2 power 2 on top, power 2 in the bottom, I suspect DNE. Over here, I see all the powers 2 and I see powers 2, I suspect DNE because it's 2 and 2 simplify, I end up with unbounded. Again, this is not 100% written on stone. That's why you have to try every time, because there are little details in there that I'm not mentioning. The other thing that I say, if one of the powers is odd, like that one was, where was the odd one? Oh no, I didn't have any. If one of the powers of the denominator is odd, there's a good chance that DNE is happening. That's another thing, one of the powers in the bottom. So that's it.